Welcome to my FX options training courses. My name is Uwe Wüstrup. I'm the founder and managing director of Math Finance. We are getting together today for an interesting topic, which is the straddle, why it's used as a vega hedge. And this is part of the series of FX options training, which we make available to our associates, friends, fans, business partners, just so you can share. I hope you like that. So let's dive right into it and let's have a look at what a straddle actually is. So, so a straddle is a combination of two options. Right? If you put your spot on the x-axis, say think of a cable, so Great Britain pound versus US dollar, and we have here a put and a call payoff with some strike. So that's a call payoff, and the other one is a put payoff. Okay, they have the same strike. So a straddle is a combination of a call and a put, both long in this case, with the same strike. You could also have a short straddle than this. Short straddle. That's probably the better way to explain why it's called a straddle. It's called a straddle because you've got this device that you can put on the ground and take a block of wood, you dump it on that device and it splits, it straddles the wood into two pieces, right? So that's the short straddle. Anyway, so from a trading point of view, that's it. And we want to check what its delta and vega is. So delta and vega, and once we have this clarified, we can then conclude why a straddle is used as a vega hedging instrument quite popularly. If you have nothing else in mind, then take a straddle for vega hedging. You can take any call or put option, anything that has a non-linear payoff for vega hedging. The standard options would work, but the straddles are in fact more popular for that. Now, why is that? The first thing we need to look at is delta. So let me insert on the page here. So let's have a look at delta. So vanilla delta Black-Scholes model, right? If you take the Black-Scholes delta, and that's where everything can be derived from. So we take the Black-Scholes formula, which is the value recap. Let's recap that. So that's spot discounted foreign rate times N of D plus minus strike discounted domestic rate times N of D minus. And then we can put this variable phi inside here. We indicate that. So we've got this variable phi everywhere that takes two values, right? Phi takes two values, plus one for call, minus one put option. Okay, so we got a formula that combines everything for calls and puts. And then with that, you can take derivatives. We won't get into the details today. So I'll just tell you what the answer is. If you take the derivative of V with respect to initial spot, that's what delta is, right? Spot delta, and you will get phi times, so it's basically the coefficient of S, right? So phi times the discount factor with the foreign rate in phi d plus. So that's delta, and then we get vega, dv, d sigma. That's called vega. So that is, well, again, we'll tell you what the answer is. So that's going to be a discounted spot at the foreign rate square root of time to go t in prime of d plus, right, where in prime is the normal density. Right, and I think the rest is clear. D plus and minus, maybe as a refresher, I should put it up here. So D plus and minus, what is that? That's the log of forward over strike plus or minus 1/2 vol squared cap t over vol squared root t. That's what d plus and minus is. And f is, of course, the forward rate e, the s times e to the rd minus rf t forward rate. Okay? Right, so two things to analyze. What's the delta of a straddle? So we need to check what we generally do to get an at the money notion in FX options is we take the strike that gives you the same delta for call and put. Well, obviously not exactly the same up to a sign, right? Because call deltas are positive and put deltas are negative. So so we set the call delta equal to minus the put delta. That's why we get the strike at the money in a typical FX setup. So let's insert another page and derive that. You might have seen it before, but let's do some math today. So now we're on the same setting. So call delta is equal to minus put delta. How do we the strike that does that is what we want, right? So let's just plug in the formulas here. So we get phi is equal to 1 for a call. So that's going to be a discounted n of d plus is equal to minus. Now for put delta, we take phi equal to minus 1. There is already a minus. That's not the minus I'm talking about. So there's a put, and we get another minus here from phi, and then discount factor n of minus d plus. All right. Okay, now it's time to cancel a few things. So that the two minus signs go away, they cancel, and the discount factors go away. So there's not much left. What we are left with is n of d plus is equal to n of minus d plus. All right. N is the normal cumulative distribution function. So this is this function here going up from 0 to 1. This is increasing, right? It is also symmetric, but we don't need that. But the main thing is that it's increasing. So that means it's a one-to-one function. Okay, so we can skip it. So taking this from here, this is equivalent to d plus being equal to minus d plus. And obviously this only works if d plus is equal to 0. So 0, that has to be the ratio of log forward over strike plus. So easy to remember if you work with plus and minus rather than 1 and 2. 1/2 vol squared cap t over vol square root t. Now if that is supposed to be 0, the numerator would have to be 0. So then we can put the log on the other side right away. So the log of forward over strike is equal to minus 1/2 vol squared cap t. And that again, if you take everything in the exponent, is going to be k is equal to f times e to the plus 1/2 vol squared cap t. That's the result. So this is generally referred to as the ATM at the money strike, and that volatility here is referred to as the at the money volatility, ATM vol. All right. Slightly bigger than the forward, as you can see, because it's multiplied by a quantity e to the plus something, which is bigger than 1, so that at the money strike will be higher than the forward. Okay, good. So we also remember the condition d plus is equal to 0. That leads to this condition of the same delta for call and put, which is not equal to the forward, by the way. It's bigger than the forward. Okay, so we got delta derived. And so the conclusion is that delta call is equal to minus delta put. That's what we wanted, and therefore delta call. Let's start with the puts. Delta put plus delta call is equal to 0. Right, so that means that the straddle delta is 0. If you take the at-the-money strike, then the delta of that combination of call and put called a straddle is 0. It means that if you trade a straddle anytime with this particular strike, the at-the-money strike, then you would get 0 delta. Nice, right? Nice and symmetric. So the next thing we wanted to check, we are about to find out why a straddle is used as a vega hedge. So we need to check what vega is. Let's insert another page. So what is vega? And what property does it have, right? So vega for call and put, so indicated by vanilla, is equal to a discounted spot square root of time times in prime of d plus. And the question that I'm going to ask is, which strike maximizes this vega? Okay, which strike maximizes this vega? Well, look at it. Where's the strike? The strike is hidden, right? We can't even see it, so it's hidden in the D plus. So the terms before, let's indicate that here. If you look at that part here, all of this junk doesn't have any strike K, so it's irrelevant if I'm asking where the max is. The only relevant bit is the in prime function. So then here, this one contains K. The rest does not. So if we take a look at the function n prime, x, that's a very well-known function. It's the normal density, standard normal density. Right, so we've got here d plus on the x-axis. So it's a standard normal density. So what I want to say is where is the max, right? You can do maximization by visual inspection, right? Of course, it works if you take first order conditions, set the derivative equal to 0 and do all the algebra. It's not necessary because we can already see that the max is sitting right on the top, right? No argument here necessary because we know the normal density function. So the max is at the point where d plus is equal to 0. Right? And then the good news is that this is actually something we just talked about before. That's the same as for the same delta for call and put. So again, this would be equivalent to the strike being forward times e to the plus 1/2 world squared cap t. We don't have to re-derive it because we just did it. It's the same condition. Okay. In summary, the straddle has two relevant properties. Let me draw the straddle again so we know what we're talking about. If you take the straddle with this ATM strike, not any strike, right? Let's take the ATM strike. Then we have two properties for the straddle. Number one, it's delta neutral. And number two, it's got a maximum vega. Right, why is that important? Why and how does the hedging of derivatives work? Generally, you do a delta hedge first and you do it very quickly before the spot wanders off. So normally nowadays it's all automatic, right? You trade some derivative, delta hedge is automatically done at the same time, so you would pick up exactly the spot ref you need for your hedge. So imagine delta hedge is done, and then it's time to clean up. You can have coffee, you can call your mom, you know, whatever you want to do, and then you go back into your vega hedge. World doesn't move as fast as the spot moves, slow moving market data, as you call it. And then you can do your vega hedge. You take this straddle for vega hedging because it picks up maximum vega. You can't get better than that, right? Means the notional overall is small. Right, so maximum vega using that straddle. And second good news is you wouldn't mess around with a delta position that you've already established, right? So you leave your delta untouched because it's already hedged, and then do a vega hedge with a straddle, right? Whether that's always the best thing to do for vega hedge is a different question, but in terms of a good standard, if you have no better idea, then you can always think of this straddle as a best possible vega hedge. Hopefully that will help you remember it. So that's why straddle is used for vega hedging. Let's have a quick look at an example. Okay, let's let me show you your example in figures. Right, we've got here an option calculator. That's the calculator that you'll find on Icon, by the way. So we've got here prepared sterling dollar. So that's cable. We can put in a spot ref 140. Right, just to be keep it simple. I'll use 140 for both. Put an offer, so we freeze the spot ref, right? Then I've got a straddle 3-month contract. I'll put in here as a strike ATM, and then we'll see what happens. Most systems normally back out the ATM strike for FX options automatically. So let's see. There's a total notional here. Okay, so it did in fact back out a strike 140.10. Let's have a quick look at the forward rate. For that, we need to click and open the market data. So your forward points, I don't know points, I want the rate. So the forward rate, as you can see here, is 140.03, and the at the money strike that I can calculate it is at 140.10, so it is bigger than the forward. That's to be expected, right? It's not much, right? But it is bigger. So it seems like as a quick sanity check is not obviously wrong, so probably incorrect. Let's have a look at the delta positions. So you can see here your spot delta is 50,681 for in dollars, I think. So they say that for the call, and for the vanilla put, it's minus 50,568, so up to a couple of euros rounding issues. The total delta position, as you can see here, is less than zero. So it's a numerical zero, right? So if you pick that strike, yeah, the money strike, you do get delta neutrality. And the vega is maximum, so you take 20,000 vega here. That number means if you shift the vol by 1% absolute, right? So going from 6.6, as you see here, to 7.6, that would be an absolute change of 1%. Then the straddle price would go up by $20,000. So that's a maximum vega. Let's check if that's true. If I pick a strike slightly higher, so 140.25. So suppose I did that. Then vega is slightly smaller, right? So you see, if we take 140, let's take 145, maybe that becomes clearer. Then your vega goes down to 13,000 from 20,000. Also, if you take the other side, you can take a 135 and go down. Then vega is also about 13,000. So you really need to be in the center of activity that was 140.10, I think. To go back, you'd see maximum vega position here. So that's how you would illustrate. Okay, so in summary, straddle is a combination of a call and put with the same strike. The traded straddle is the one that has the at-the-money strike. That at-the-money strike is given by forward times e to the plus 1/2 vol squared times cap t. And you read off ATM vol from a supplier, from a vendor, from a market data sheet. That is the vol for that strike. For this strike, you get the same delta for call and put. So consequently, a straddle will have a 0 delta, and it's got maximum possible vega, and that's why it's a popular vega hedging instrument. All right, that's it for today, and I'll see you soon.